Hi, everyone. This is Sebastian Traeger. I'm the managing director with reliability.com, and we're back for another Reliability 4.0 episode. As always, we're on a mission to help make the world a more reliable place. We do that specifically as a company through the power of root cause analysis, but we have guests on who do that in many different ways. And today, we are thrilled to be joined by Sean Walker. Sean works at Washington River Protection Solutions. He's going to tell us a little bit more about that. But Sean, we are thrilled to have you on the call. Thanks for joining us.
Yeah, thanks for having me. I'm glad to be here.
Yeah, we really appreciate that. Well, I always like to start off by just having, my guests tell us a little bit more about the company and just sort of how they got there, and then we'll drill down a little bit from there. So how did you come to tell us a little bit more about Washington River Protection Solutions and how you came to work there?
So Washington River Protection Solutions, WRPS, we're located in Eastern Washington in the Columbia River Valley. And it's we're out at the Hanford nuclear reservation. We're responsible for the cleanup of tank waste from the Manhattan Project and the development of nuclear arms from World War II through the middle of the 80s when the U.S. stopped making nuclear armaments. That process, which creates a lot of nuclear toxic chemical waste, they took that waste and stored it in large underground tanks, and so the U.S. Department of Energy has had contract work out on the Hanford Reservation for since the 70s, doing monitoring of that tank waste. And then we're moving to a new phase of the mission, which is to then begin vitrification, or the making of glass out of that waste. The reason we do it with glass is because it creates a stable matrix to encapsulate the waste to prevent it from leaching into the groundwaters of the Columbia River. So that's the company I work for. We're like I said, Department of Energy contractor.
Okay.
So what I do is I lead the reliability engineering team, and we're building the reliability program for equipment reliability and asset management. Prior to 2020, the major focus was monitoring tank waste and waste elimination through an evaporative process. And it was a very slow going kind of a deal. They've been building the vitrification plant since, I want to say, 1987, I believe. I could be wrong. I don't know the exact time when that started, but it's been quite a while ago that they started building the plant, and it's supposed to come online in 2025. We've actually got the two melters that are going to turn the waste into glass started up and doing their cold runs. I say cold run, they're running at around 3,000 degrees Fahrenheit. So they just don't have any nuclear waste in it to create glass.
Okay.
Or, they're creating glass, but it's clean glass. It's not the nuclear waste glass.
Good.
They didn't have.
I was going to say, I want to ask a couple other follow-up questions on that, but before we dive in, because that's just fascinating. I feel like we can spend a lot of time talking about that, but just so we get to know you a little bit better, tell us a little bit about your family or one thing you like to do outside of work, just so we kind of know who Sean is outside of being a reliability engineer.
So I'm married and I have two children. Both of them are both under 10. We don't like a lot of people in our area go out and spend a lot of time hiking and stuff. My wife has a ton of allergies, so we don't get out there and do that much of that. But we spend a lot of time, puzzles and games with the children. That's kind of the most of what we do is just hanging out with our kids and having a good time with them right now.
That's great. So, hey, we're always looking for a new family game. What's a recommendation you would make?
There's a game called Beast of Balance. It's a really cool game. You have these oddly shaped polygonal representations of animals, and they sit on this platform, and you have to balance it, and it creates a tower, right? But it's it interacts with smart TVs or tablets and that through a Bluetooth connection, and it builds this world as you stack the animals or other pieces that do different things with the animals up, and it creates new animals, and it's really kind of neat. And then in the background there's a volcano, and if you topple the tower over, you have like 10 seconds to rebuild the tower in whatever shape you can get it in before the volcano erupts, and that is the end of the game if the volcano erupts. So
very fun.
It's really fun. It's really kind of calming, and then all of a sudden, if somebody puts a piece down that's not quite balanced, the whole thing falls over, and it becomes a race. So it goes from calm to just chaos. Yeah, it's really fun.
That's great. All right. Well, thanks for that recommendation. That's great. Well, let's dive back into your work. So thanks, for sharing a little bit about you. Back to your work. So I just have a very, how much nuclear waste is there underground that you're going to convert to glass?
That is not something I can disclose.
Okay. But obviously it's more than a couple of gallons.
Yeah. And so they're in tanks. The tanks are sealed. And part of what we do is we verify that the tanks aren't leaking.
Okay.
And a lot of this you can find if there's a really good YouTube video, History of Hanford, I believe is what it's called. That goes into it's on YouTube. It's open to the public.
Right.
You can go watch it. I think it's about an hour long. It's been several years since I watched it, but it's got some really cool information about the early years up to, I think, probably 2010, 2015 time frame when they made the video. But again, it's been a while since I've watched it, so I don't exactly remember all those dates. Right. But there's a lot of waste from the generation of nuclear armaments, and so right now we're working to retrieve those tanks so there's single shell and double shell. We're taking the waste out of the single shell tanks because those are at the end of their life, putting them in double shell tanks, and then that's going to be treated into a glass, which will immobilize the waste and prevent it from further potential propagation into the environment. Eventually those become big blocks of lead, but that's like 250 million years from now.
Wow, that's unbelievable. All right, well, that's just fascinating. Talk to us about in a type of a role like that. What are the KPIs that you have like for you in your role or as an organization? How do you measure success in that process? Obviously, one goal is like don't let it leak. So that's kind of a big picture. But in all seriousness, what are those KPIs in that kind of a field?
So right now, we look at performance indicators a bit differently. Simply because we're going from a posture of just kind of babysitting the waste and making sure that our tanks and stuff are okay. There's an annulus around the tank, so you've got a space, and so they do a lot of things that look into that space. They have cameras that they can put inside the tanks to look at the waste levels in the tanks and stuff like that. But from a key performance indicator, we as a company, we haven't gotten into those very much. In the engineering realm, recently we started tracking system health at a higher level using a kind of key performance indicator, kind of a red, yellow, green scale, or red, orange, yellow, green rather. And that's been something we started doing in the 2018 time frame, and it's largely because we don't up to 2025 we've not been a production oriented company, program organization. It's been just make sure the waste stays where it's at. And now we're the infrastructure for the vitrification plant and the connections between the vitrification plant and the tank farms has been made up, and we're getting ready to start sending that waste in the next couple of years to be immobilized in the vitrification process. And so we'll start seeing performance indicators come up. We use guidelines right now. We call them key performance guidelines, and what it really is these are a set of goals that you want to get to within a given. And we operate by fiscal year, so within a given fiscal year. To meet to call success for those programs, and those are set by things like development of the reliability program, for example, has some performance guidelines that we're having to meet. They've got ones for waste evaporation, which is where we reduce tank volume by evaporating off the waters that are in it and concentrating and sending it back. stuff like that. So it's not, we don't really use key performance indicators in the sense that most of the rest of the industry does, especially those that have mature reliability programs and mature system engineering programs. We're still in the foundational stages of those two, and so it's a bit of a different. We use a bit of a different approach.
Well, yeah, and I appreciate you saying that. I do think whenever you're in an early stage or you're setting something up I come from a world of doing some technology startups. And so in our world, in the building phase, KPIs are going to be a little bit different than when you're in market and driving results. And actually, you mentioned this. I love using, just for other listeners out there, kind of a very simple red, yellow, green kind of system of how are we doing, right? So it's less like we need the actual hard numbers and more we just need a sense of how we're doing. So I appreciate that's what you do. In terms of top priorities, then, is everything focused on let's get operational? Is that just the overarching priority that you're focused on?
So it's an interesting question. So we are a nuclear site, and when you look at priorities, the first thing we have to discuss is nuclear safety. And so we put a lot of effort into ensuring that our operational systems that are in contact with either waste or chemical, or the chemical waste or the nuclear waste, that those systems have active safety features that will prevent exposure either to personnel, the public, or the environment. I mean, that's ultimately the major goal, is to make sure that we don't get somebody sent home in a different condition than they were when they arrived at the work site. And the secondary to that is the environmental mission, and that is why Hanford exists. It's why the WRPS exists, and other contractors throughout the years have done this work. It's the environmental cleanup, where the mission is that we turn the Hanford nuclear reservation back into green space, right? And 50, 100 years from now, the goal is that there are no buildings out there, right? So each one of us is actively working towards that goal. And then production becomes, production is kind of the third thing we care about.
Okay.
And so, if you have a failure within a safety system, everything stops, because even those things that result in a safe failure, because we don't want to harm the people that are there. We don't want to have a release to the environment that can affect personnel in the surrounding area, and we don't want to set the mission back with an environmental release as well. And so production really is our lowest of the three priority type things that we care about, simply because then that if we were production oriented, that would kind of fly in the face of the actual mission of the Department of Energy.
Sure.
So
well, and for you all, a failure it's not lost revenue, right? It's, as you were mentioning, health, safety, environmental, potential catastrophe. So you've got like sort of a, things go wrong, it could be really terrible.
I mean, there is a lost revenue aspect of it, and that is like I said, there is a lost revenue thing, but that's less of a concern, simply because it's, if we have a failure that results in lost revenue, that's fine. But if we have a failure that results in let's say a release, not only do you have lost revenue, but you have the release, you have the impacts from that. It'll cascade pretty quickly.
Good. So let's talk innovation. So we always like to talk innovation as it relates to what folks are doing in the reliability space. What would you say are some of the more innovative things you've seen, either in AI or IoT, as it applies to your work? Have you seen some of those innovations? What are they that you're able to share?
So, when we look at those type of things, our program is still in its infancy. I've been working at it for about 5 years now, and so we're about halfway there as far as getting a program that's integrated into the rest of the organizations on site. And so, we spend less time with innovations that you see in industry, because we're still program development. I see a lot of the changes in like condition monitoring tools for vibration and thermography and ultrasound, those things that are more fundamental to equipment health and understanding equipment health. Those innovations tend to be what we spend most of our time with right now. We've actually just gone and done a platform change for our ultrasound testing, to from UE systems to SDT ultrasound. And it's, just from a form and function standpoint, but they have a lot of new things in ultrasound, like the new ultrasound cameras. And I know what's it? UE Systems has one, SDT has one. I think Fluke has a camera, and what it does is it basically has, a whole bunch of ultrasound sensors and a camera, a high resolution camera, and then it when you point it at an area and on the camera's screen, it overlays a signal on the camera to show you where ultrasound is being generated. That's a really neat thing. And so when we look at innovation, the industrial Internet of Things, that type of stuff, we're not there yet for, we don't use that. We're not that deep yet into that art of the things we look at from innovation standpoint is technology movements in tools that assist us in our program development.
Okay, that's helpful. That's great. Well, one final word, just as you think about one thing in your job or field of expertise that you think other reliability engineers need to hear. So as you've kind of thought about your career and things you've learned, what do you try to impart to folks, kind of a word of wisdom?
The thing that I find to be the most difficult, and this is probably pretty common, but it's significantly underrated as far as things that get discussed at conferences, and that is communication with decision makers. J.D. Solomon has a book called Communicating to Decision Makers, how to get your boss's boss to understand. And that becomes, I think that's probably the biggest challenge, at least from the perspective of building a program from scratch. Because, Hanford's been around as a waste monitoring and cleanup effort since the 70s. And so we've got, a whole bunch of time where we had one culture that was just keep the waste where it's supposed to be, and we don't want to move it anywhere. And now we have a paradigm shift where we have to move waste across the site from one facility or set of facilities to a different set of facilities with an entirely different mission, and that is to turn it from liquid waste to solid waste. And so being able to communicate with the decision makers becomes an extremely difficult challenge when you have to describe, we got to think more about, we don't want to think less about safety, but we have to start thinking more about the reliability of systems that are necessary to move the waste. The safety systems want to keep the waste where it's at, because if something goes wrong, they stop that movement, they stop that production. Whereas, the mission critical systems, those things that are required to move the waste from one facility to the next, we've not paid attention to those things. And so getting that, that culture of keeping things where they are, and, that is a difficult thing to change, because you don't want to reduce safety, but you do have to increase movement in this case. And, having the focus, being able to focus on how to speak to those managers, higher level individuals in the organization, especially from an engineering perspective, can be quite daunting. I'm in a bit of a unique position because I have engineers that work for me. I report to an engineering manager. And so, I have a lot of experience, in being able to communicate to those upper management levels, but you have to be able to do it in a way that helps them understand what you're actually saying. Because there's always that, what's the elevator pitch, right? And unfortunately, that cliche actually holds true when you're talking to an upper level manager about something that they don't have really any experience with, and you have to be able to put it in terms that they can get within 2 minutes. Otherwise, it's they forget it as soon as they walk out the door, type of a thing.
That's good.
So
that's
what I would really drive a focus towards.
That's great. And that was J.D. Solomon's book. Remind me the title again. Oh, you've got it right there. Back it up a little bit. It's a little blurry there. Okay, there you go. Decision
Hold on.
making. Good.
Communicating to decision makers. Let me turn the blurring off here, and that
Yeah,
should
that's
help.
great. That's great. Well, thanks for that recommendation for folks. I'm sure. Yeah, that sounds. I agree. That's one of the. That's a challenge anywhere. I do think in the reliability space, especially, that can be a challenge. So I think any resources that are out there can be helpful for folks.
Yeah, let me.
Well, Sean. Yeah, go ahead.
This is the book.
Yeah, reliability, risk, and resiliency. Yeah, communicating to decision makers. That's great.
Yeah,
Well, thanks, Sean. It's great to have you. Our guest again was Sean Walker with the Washington River Protection Solutions group. It's fascinating just to learn about the space you're in. Thank you for serving in the way that you are. My goodness, I think we all feel safer because folks like you take your work seriously. So we appreciate it and appreciate all the work you do. And to all the listeners out there, again, we're about helping engineers and anyone else really take steps to leverage technology, to think innovatively, to communicate well, and to put into practice some of the big ideas in making practical changes. So again, this conversation with Sean, thank you again for being here. We do appreciate it.
Have a good day. Thank you very much.
Yeah, and again, if you're looking for RCA training or resources and materials, please check out reliability.com. If your company is looking to dig deeper into RCA, then our in-house software can help you do that. Easy RCA. Again, thanks for checking in with us. That's all for today, folks. Let's go forth and make the world a more reliable place. We'll see you all on the next episode. Take care.